Okay, after considering the formal definition, it says given our limit and epsilon, use the graph of f to find the largest delta such that it satisfies our inequalities of our definition. So we're going to do a little bit of side work on this. The first thing we're going to do is let's work with the limit itself. Graphing this right off may not be quite that easy, but let's see if we can simplify this a bit. So the limit as x approaches 3 over 2, the limit of the function. So let's take our function. Can this function factor is my question. What is in the numerator? Difference of perfect squares, right? So we have, that would just give us 2x plus 3, 2x minus 3. So what do we have right there? Yeah, we have, this is going to simplify. So that's going to equal, to see a simplified version of this, 3 over 2, and we have that. Okay, so it told us to use the graph. So I'm going to graph 2x plus 3. Let me pause it. Okay, just to give a rough sketch of this 2x plus 3, this is our equation to take this given information and limit as x approaches 3 over 2. The limit is approximately 6, so let's just have a rough sketch there. Now, with this definition, we're trying to find delta. They tell us epsilon, though. They say epsilon is 0.01, so epsilon is going to be within our distance of our L, so that would be like 6.01, and that's, let's pretend that's like 6.01 region and one below that, so we'll say like that's 5.9. So they're saying if this is epsilon, what does delta, what's our largest delta, have to be to satisfy our definition? Okay, so we're going to do some calculations on this. Okay, so we're going to come over here and we say they gave us epsilon. They want our epsilon to be within 0.01 of our limit. So we use a lines y equals 6 minus 0.01 and 6 plus epsilon. So it gives us this inequality. Our function's going to have us in between those values, and we're just going to do some, and that's to get us within this region. This is the first equation of the line. That's the other equation. So let's do some algebra. The first thing we're going to do is we're solving for x. So we're going to subtract 3 from both sides. Just do some basic. That gives us what? 2.99. Now what do we do next? Divide everything by 2. Good. So we're going to get 1.495. Double check these for me. And 1.505. So basically it's going to say this is going to be where our x needs to be. So delta, we're looking for the largest delta that we can have. So the largest delta is going to be over here. So we would take 1.505 and subtract out the value x was approaching, and we will find out that it's 0.005 within 0.005 units of 3/2. So let's look at that. Let's see if we can tie that in. So delta must be within 0.005 units of 3/2 for those to guarantee that we're going to be in our epsilon region of 0.01. Okay, so we're not going to work through the entirety of number 6. It's very similar to number 5, but I will just help you set up your inequality. For the given epsilon, we're going to use the lines y equals 27 plus our epsilon and y equals 27 minus our epsilon to ensure is that we're in the region 26.99, that was from the first equation, is less than our our function's x cubed in this case, 27.01. So we must have a delta less than or equal to the minimum of the distance in this case. So you would just solve this and determine your delta. Okay, so that's another one. We're going to look at the next problem. So use the definition to prove that the limit exists. Okay, so to use the definition to prove that these limits exist, we're going to establish, remember we're working with these two inequalities from the definition, and we have to show the relationship between the two. Okay, so we must show for any given epsilon greater than 0, show that given any, this is our side note, any epsilon greater than 0, we can find a delta greater than 0 such that those two inequalities hold, such that both of them hold. Okay, so just kind of like we did in the last example, they gave us an epsilon and we had to find delta that satisfied that. But now we're going to do it, it's a little more extensive on this end because this is the proof side of things. And it's not always necessarily intuitive, but let's just break it down for a minute. So first of all, let's label what we think. This is our side note of what we're trying to do over there. Let's label some of the stuff we do know. What's our f of x in this particular case? Good. What about our L? What's our limit? 15. And what about our A term? 3. Okay. Okay, real quick, that was pulled from formal definition. Is basically, here's our side notes up here. This is where we're going with it. We're just identifying our components here. All right, so let's look at our delta statement here. And so let's convert it to what our example uses. So let's put in, we had 0 less than, this is just going to be x minus a. So what's ours going to be for this particular problem? 3, right? A is 3, is less than delta. And then let's consider such that, and then we'll consider then, if that's the case, then we'll have f of x. Let's convert this to using ours. F of x, what's our f of x? 5x minus what's our L? 15 is less than epsilon. Okay, so what we want to do to use the definition, we want to show that given any epsilon greater than 0, we can find a delta greater than 0 such that these two inequalities will hold in this particular case for this given example. Alright, so we need to try to find a proper choice of delta. So we'll examine the epsilon statement. Okay, we're trying to find a proper choice for delta, so we'll look at the epsilon. We have this here. And we're going to simplify this a bit. Here's a little bit of the tactic. So can anything be factored or grouped here in this? Because I ultimately would like it to look something like this. I have to verify one with the other. So at some point, either I try to make this one look like that one, or that one look like this one. But since delta is what we want to try to find first, I'm going to consider the epsilon statement and see if I can get it over here. So first of all, x minus 3, I'm thinking I could probably factor here or take a GCF out. So if I took a GCF out, what would that give me? 5x minus 3, and I'm liking that. Okay, properties of absolute value says we can pull that 5 out front. So that would just be 5 absolute value of x minus 3 is less than epsilon. Okay, but when I'm looking at it, I have just absolute value of x minus 3 over here. So what can I do to make this look like this? Just this right portion of it. Divide by 5. Good, right? So if I was willing to do that, then I can see that I would just have epsilon divided by 5. So in this particular case, I could say delta, if we choose delta to be epsilon divided by 5, that's what we want to be able to choose. And we want to plug it back into the delta statement and see if we can, if that works for us. Okay, so we have a delta that we're going to work with. So we're just going to plug it. We're just going to focus on this right-hand side. So if I have x, absolute value of x minus 3 less than, in place of delta, what can we use? Epsilon over 5. Good. So if I put epsilon over 5 here, okay, to establish our definition, what does this need to be? Just epsilon, right? So we found delta, but now we're working with that. We needed to have just an epsilon. So what would I need to do? Multiply everything by 5, right? So if I multiply this by 5 and I multiply this side by 5, that would give me 5, which is nice, but then also, is it back to the original that we had here, which is equivalent, right? This is equivalent to this, so therefore we've established that case. So really, it's finding the delta, proper choice for delta, and examining it in the epsilon statement. So that is equivalent to our 5x minus 15 is less than epsilon, which that's equivalent. So